every nth value, for example, we have a data point, data set 10, 20, 30, 40, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. For example, this is our whole population. Okay. From this, I want to pick only every second value as a sample or every fifth value as a sample. So first value, after that, second, third, fourth, fifth, sixth value, after that, seventh, eighth, ninth, 10th, 11th. For example, if you have 110, we'll select this one. Every fifth value as a sample. Is this understood? That is systematic. Next, convenience. Convenience is nothing but domain experts. Okay. Next, cluster sampling. Cluster sampling is the whole group will be selected as a sample. Okay. Example for the same data set, if this is our population, example for cluster sampling. First, we should divide them into the groups. One group, 10 to 30. Second group, 40 to 60. Third group, 60 to 80 or whatever it might be. Fourth group is this one. We'll pick this whole group or this group or this group or this group as a sample. Okay. In stratified sampling, we'll pick some from first group, some from second group, some from third group, some from fourth group as a sample. Okay. This sample mean will never be equal to population mean. For example, if we take average of 10, 40, 65, 85, what will be the average? 10, 40, 65, 85. Average of this. Average of this. 50. 10 plus 40 plus 65 plus 85, that will be 200. 200 divided by 4. 4 number, I mean 4 numbers we have. 200 by 50. Sorry, 200 by 4. That is 50. 50 is the average of this sample. And if we calculate the same average for population, that will come around 55 or 60. Right? These two numbers will never be same. Unless and until if all the numbers are equal in population and sample. In population also, if we have all tens. Okay. In sample also, we have all tens. Average of sample and average of population. In this scenario, the average will be same. There will be no sampling error, right? But here, when we have this kind of data where the sample mean is not equal to population mean, then we'll have sampling error. Okay. In 100% of the cases, we'll have sampling error. Is this understood? What is sampling error? The difference between sample mean and population mean. Okay. It should be in a order. Sample mean minus population mean. It cannot be population mean minus sample mean. It is always sample mean minus population mean. Is this understood? Yes. Population is denoted by capital N. Sample is denoted by small n. Okay. Is this understood? Yes. Shall we move on? Changes values. Not even close. What is a variable? Container which stores the data, which stores the value. Is this correct? Which stores the value? Is this correct? Variable, for example, if we just write a equal to 10, a is a variable. But what does a store here? No. Address of 10. Address of 10. 10, for example, is stored in our database here in this portion. Okay. For this place, we'll have an address. For example, A12345. This is the address of this 10 in a database. A will store address of 10. 3, 4, 5. And whenever we call this A, that will go to this address and pick up the value that is present at this address and then give us the result. Is this understood? So variable, whenever someone asks what is a variable, your answer should be variable is something which stores the address of the value. Address of the value. What is the meaning of address? In Excel also, for every cell we'll have an address, right? What is address? What is the address of first cell in the Excel? A1. A1, that is the name of the cell, or we can call it as address of the cell. Is this understood? Yes. We have two kinds of variables in statistics. One is quantitative and qualitative. Anyone know what is quantitative and what is qualitative? Quantitative, any data which can be measured numerically. Any data that can be measured numerically. Meaning of this? Meaning of this? Meaning of this? Just simple one line statement. Any data which can be measured numerically. Whole numbers, decimals, and examples. Any examples? Everything that we have written here, sales, weight, height, temperature, right? Everything which are in numbers, numeric format, that is nothing but quantitative. Now, what is qualitative? Which cannot be measured numerically. Example. Definition is understood. Examples for quantitative is understood. Examples for qualitative. Qualitative, anything that can be categorized. Might be what? Product names, right? Every examples in the categorical, we will not be able to measure that, but we will be able to group them. Simple. Company names, we will not be able to measure, but we can group them based on the industry. IT industry company names, marketing industry company names, sales industry. Is this understood? Yes? Yes or no? Yes? Next. These are two types of variables, and in quantitative, again we have two types. Quantitative is again divided into two types. One is discrete, one is continuous. Meaning of this discrete and continuous? Anyone? Meaning of this discrete and continuous? What is discrete? Not in an order. Okay. Discrete, discrete and continuous. Discrete, no decimal. 100% correct. Discrete is simple whole numbers. Continuous is all the values including decimals. Okay. Examples for discrete. Examples for discrete. Whole numbers. Examples for discrete. Simple. 1, 1, 2, 3, 4, 5. Okay. But one situation based. Number of students. Okay. Number of students. Correct. Whole numbers. Number of students. Next, age. Okay. Do age come in discrete or continuous? Discrete or continuous? If we just consider, for example, our age is 15, okay, 15 years. This is discrete. For example, if we say our age is 15.5, okay, 15 years and 6 months. We can assume in that way also. We can proceed in that way also. 15.5, right? So age will come under both of these things, but based on the situation. Okay. Next, generally we say in discrete. Yes, correct. Number of cars. Number of cars in a parking lot or whatever it might be. Number of students. Number of products. Number of salespersons. Number of locations that we deliver. Right? All of these things. Now, examples for continuous. Example for continuous: height, temperature, width. Next, weight. Okay. Next. Okay. Number of bank accounts. Will that come under discrete or continuous? Number of bank accounts. Why will that come in continuous? Bank accounts, not balance. Bank account balance comes under continuous, but we are talking, for example, you have 3 bank accounts, right? That comes under discrete. No one in this world can have 2.5 bank accounts, 3.5 bank accounts, right? That comes under discrete. Next one. Number of children in a family. Discrete. We can't say we have 3.5 children. We have 4.5 children in a family, right? So that is the difference between discrete and continuous. Next. Serial number, energy. Okay, correct. Next. Length of a river. Length of a river. Length of a river. Continuous. Okay. Because that is not fixed. It keeps on flowing, right? It can have decimal values, right? That is continuous. Next. Okay. Variable, qualitative, quantitative. Okay. Next we'll go to central tendency. Meaning of the central tendency. Central tendency. Measure of central tendency. Measure of central tendency. Central values of the data. Meaning of this. Meaning of this. For example, we have a data set 10, 20, 30, 40, 50, 60, 70, 100. Okay. Measure of central tendency. That means central tendency always talks about mid portion, central portion of our data. What do we have in this central tendency? We'll have mean. Mean is average of the whole data, average of 10 to 100, average of all of these values, average of all of these values, 55. Okay, so that is the average value. Next, median. Middle value. What is middle value? Middle value, how many values do we have? 4, 5, 6, 7, 8, 10 values we have. We have 10 values, even number of values. In median, there are two scenarios. One is even number of points and one is odd number of points. If we have odd number of data points, middle value will be our median. If we have even number of values, average of middle two numbers. Okay, average of middle two numbers. But in this scenario, what will be the average of 50 and 60? Average of 50 and 60 will be our median. Is this understood? So 55 again. Okay. Next. Mode. What is mode? What is mode? Mode. Most frequent I mean, most frequency value. What is frequency value? Repeated most number of times. Okay, repeated most number of times. Most number of times. In this data set, in our example, what is mode? What is mode? No mode, right? Every value is repeated only once. There are three things in mode. One is single mode, one is bimodal, one is no mode. Okay, the data that we have taken comes under no mode. Okay, what is bimodal? What is single modal? Single modal, if all the numbers repeated, I mean, if all the numbers are repeated only once, that is no mode. Single mode, meaning of this, only one number is repeated most number of times. Repeated most number of times. Is this understood? Single model is nothing but only one value is repeated most number of times. For example, if I change this value 80 also to 10, 90 also to 10, 10 will be our mode. Okay. For example, single mode, that means 10 is repeated most number of times. And next, one value is repeated most number of times. Here in our example, 10. Next, for example, I'll change this value also. This is 20. I'll change this 30 also to 20. This 40 also to 20. Now, it is bimodal because two values are repeated most number of time. 10 is also repeated 3 times. 20 is also repeated 3 times. Right? We have two modes. That is bimodal. Is this understood? Multiple values repeated most number of times. Good. Multiple values repeated most number of times. Is this understood? Yes. Central tendency. Okay. Next thing. Next, what shall we see? Frequency distribution. What is frequency distribution? What is frequency distribution? Let me give you an example. Okay. Our data set is 10. Frequency distribution of this data set. Frequency distribution of this data set. Two data repeated equally in most number of times. Spread of repetitive data. Yes, exactly. Spread of repetitive data. Yes. What is frequency distribution of this data? Range of values occurs. Range of values occurs. Okay. How many values are there? How many distinct values are there? How many distinct values are there? How many distinct values are there? 7, 5, 8. What are they? What are they? Forget about how many. Tell me what are the distinct numbers in this data. 10, 15, 20, 25, 30, 35, 40. Okay. How many? 1, 2, 3, 4, 5, 6, 7. 7. Now frequency of 10, 5, 15, 1, 20, 4 times, 25, 1, 30, 35, 2, 40, 2. This is nothing but frequency distribution. That means each value is repeated how many number of times. Next, there is one more thing, cumulative distribution. What is that? Cumulative distribution. Cumulative distribution. Add upon another. Cumulative distribution. Sum of all frequencies. See, this is normal frequency. There is one more cumulative frequency. That is nothing but for 5, it is 5 only. For this 15, it will be 1 plus 5, 6. Current value plus previous value. Next for 4, for this 4, it will be 4 plus 6, 10. For 25, 10 plus 1, 11. For 30, 13. For 35, 15. For 40, 15 plus 2, 17, right? 17. The last value in the cumulative frequency is nothing but total number of values in our data set. Is 17. That means in this data set, we have 17 values. Okay. It is similar to percentile. We'll come to that. Is this understood? Frequency and frequency. Yes. There is one more thing, relative frequency. What is that? Relative frequency. Yes. Anyone? What is relative frequency? Relative frequency. We have discussed this already. We did discuss about this relative frequency. Convert into probability distribution. Okay. What is relative frequency? Convert into percentage. Relative frequency talks about percentage. For example, see here. 10, 15, 20, 25, 30, 35, 40. Okay, 7 numbers. 10 is repeated. How many? 5, 1. Okay, we'll take cumulative frequency. 5, 6, 10, 11, 13, 15. 5, 6, 10, 11, 13, 15, 17. Okay. First value. What is the total value? 17, right? 5 divided by 17. 6 divided by 17. Cumulative frequency value divided by total value. Okay. 11 by 17. 13 by 17. 15 by 17. Next, 17 by 17. Okay. Is this understood? 5 by 17. What will we get? Pata nahi, chhod do. Whatever value we get, that will be in a decimal format. We will convert that into a percentage. Okay. That is nothing but relative frequency. Is this understood? Yes? Yes or no? Frequency is simple. Number of times a value is repeated. Cumulative frequency is also simple. Current value plus the total number of values above it. Okay. Relative frequency, current value divided by total number of values. Okay. This is one thing. Next. Variable measurement scale. Meaning of this? Anyone know meaning of this? Variable measurement scale. This is also known as levels of measurement. This is also known as levels of measurement. Anyone know what is this? We have 4 kinds of, that means simple, we will divide our variables, we'll divide our data into different types based on the category, or characteristics or behavior of the data. See here, There are 4 different variable measurement scale. First one is nominal. Second one, ordinal. Third one, interval. Fourth one, ratio. Okay, ratio. What is nominal? What is nominal? Nominal? What is nominal? Nominal. Simple. Categories. Categories. Special order. That is ordinal. We'll come to that. Nominal is nothing but simple categorical data or qualitative data. Okay. Examples, all the examples that we have seen here for the categorical. All of these will be our examples. Gender, colors, cities, flowers, or whatever it might be. Okay. Ordinal. Ordinal. For this ordinal, the value doesn't matter, but order matters. Okay. Value is not considered, but the order is considered. For example, see here, we have students. Okay, we have student scores and ranks. Okay, student scores and ranks. Student scores are 90, 80, 95, 100. Okay, 100 first rank, 95 second rank, 90 third rank, and 80 fourth rank. Any time that we are trying to try to perform any operations on this kind of data, we will consider only rank, but not the actual value for that rank. Okay, order is considered, but the value is not considered. Okay, first rank, third rank, sorry, first, second, third, and fourth rank. Only ranks will be considered, but not the scores. Okay, next, interval. 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 Between values. Okay. Intervals will divide the whole data set into different intervals, different ranges. Okay, for example, we have like we have done here. Where is this? Like we have done here. First group, second group, third group, and fourth group. Here the interval for first group is 10 to 30. Interval for second group is 40 to 60. Here 65 to 80. Fourth group is 85 to 110. Right? This is nothing but interval. Dividing our whole data into different intervals and then analyzing that. One real-time example. Anyone? One real-time example for this interval variable measurement scale. Sales in quarter of the year. Okay, divide first quarter from 1st January to 31st March. Dividing each quarter into, dividing year into each quarter, different quarters. Okay, one more example. Weather temperature, 10 to 20 degrees, 30 to 40 degrees, 40 to 50 degrees, whatever it might be. Okay, that is one. Okay, one example. Age is also can be divided. Okay, one simple example. See here. Ola, Uber, Rapido, whatever it might be. Okay. Or not these things. We book a cab from any other platform which is not Ola, Uber, and Rapido. What do they tell us? Per day, we'll be only able to travel 0 to 300 kilometers. Right? 0 to 300 kilometers. For this, they'll cost around 10,000 rupees. Okay. Any cab, understand this example, they will give a range of 0 to 300 kilometers per day. Okay, if we exceed these 300 kilometers, we have to pay extra. For this 300 kilometers, they'll charge around 10,000. But if we exceed our kilometers, per kilometer, they'll charge around 10 to 15 rupees mostly. Okay, so here the interval is 0 to 300. There is no non-zero values, right? If we take this package, we definitely has to travel. Okay, is this understood? Yes? No non-zero values. Okay, no non-zero. That means 0 is not considered as 0. Okay, next ratio. Ratio, same like interval, but here 0 is considered as 0. As 0. We call this as true 0 point. True 0 point. Is this understood? Any one example for ratio? True 0. 0 is considered as 0 itself, but in interval 0 is not considered as 0. That is considered as a range. Any one example for ratio? GST slab. Yes, good. College allocation counseling based on rank interval. Correct. Any example for ratio? Distance. Okay. How? Salary. Okay. Huh? Salary. Okay. See here. If you join any full-time job, okay, will your salary be 0? Full-time job. They'll definitely pay you some salary. Okay. Your salary will never be 0. Does that come under ratio? Does that comes under ratio? No, that comes under interval. Okay. Now, when do we, for the same situation, for the same scenario, how can we say what will be the statement for ratio? If you join internship, okay, if you join internship, they might pay you or they might not pay you. Your salary might be 0, right? That is ratio. Non-paid internship. Internship mostly there'll be non-paid internships only. Okay, so if you join for a full-time job with a salary, that comes under interval. If you join for non-paid internship, that means we are getting nothing. 0. We are getting 0. We are getting knowledge. Okay, forget about that. We are talking about salary. Okay, is this understood? All these 4 variable measurement. Okay. All right. I'll stop it here. Tomorrow we'll discuss about measure of dispersion and measure of shape. Okay, measure of dispersion and measure of shape. Anyone know what is normal distribution? Normal distribution. Normal distribution. What is that? Data is distributed normally. Normal distribution. Normal distribution. For example, our data set, if you put that in a graph, it is like this. Okay, where mean equal to median equal to mode. Okay, that is called a normal distribution. Mean example, see here for this, for this data set 10, 20, 30, 40, 50, 60, 100. Here mean value is also 55. Median value is also 55. Mode values, for example, here in this kind of data set, if mode is also 55, that is nothing but a normal distribution curve. Real life example, we have to go with the data only. Real time example we can't give. Sales, salary, whatever materials, if average of the sales for a department equal to 50,000, okay, if you have 50 sales, 50 orders, whatever it might be, and middle value is also 50,000, and mode is also 50,000, most number of sales are done at 50,000 value, that is nothing but a normal distribution. Okay, that is normal distribution where mean is equal to median is equal to mode. And one more thing, okay, there are some divisions like this. Okay, I'll tell you this tomorrow in detail, just for your remember. Okay, there is one theory which states that most of the, I mean, 68.5% of the values will lie between plus or minus one standard deviation. We'll discuss about this in detail tomorrow. And 90% of the values lies between plus or minus two standard deviations, the middle from the mean value or median value. And 99.7% of the values lies within -3 and +3 standard deviations. Okay, this we'll discuss this tomorrow. This is called empirical rule. We'll see this tomorrow. There are some other characteristics of normal distribution also. We'll see about that. And after this, we'll discuss about histogram, box plot, scatter plot, line, column, bar chart, all of these things. After this, we'll go to probability. After this, Bayes theorem. After this, central limit theorem. After this, in probability itself, we'll see Venn diagrams, some examples. Okay. After this, we'll go to inferential statistics. Okay. All right. So I'll stop it here for today. Let's meet back tomorrow, same time. Thanks, everyone. Thanks for joining.
मला नाव होत ती तब्येत नाही म्हणून नाही म्हणलं नाही रे म्हणजे सगळं म्हणलं नवीन पुढे झाली तर गाड्या असते त्यांची तब्येत बघितली ना खूप काही नाही त्यांची म्हणजे एवढे एवढे सकाळी दोन पुन्हा 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 कसं पण होतच असतं ते माणसं ना एक पाहुणा आहे आमचा लातूर खेड्यात राहते ते पोलीस भरती झाले त्याचं मेडिकलच निघत नव्हतं काहीतरी असं माहित नाही मला तेवढं पण ती जेव्हा सक्सेस झालं तेव्हा त्याच्या मसाल्याने दिशी लावत होतो गावात तुला आणि काढली होती पण त्यांना मी